bunch more people coming, so let's let them in. Get started. So if you did open up the Google form that I sent out to the class, we are going to be learning about Table G today on your reference tables, which is the solubility curve. It was kind of hard to see the other day when I just kind of like took the sheet out of my book, so I did my best to recreate some of it on a little poster board. It's not exact, but we'll go through like how to read this in a moment. But before we do, I want to go over a few terms that you may or may not be familiar with. So just wanted to refresh some terms before we start looking at G. So we'll hang it up first. So a few terms that you should be comfortable with are solute, solvent, solution, unsaturated, saturated, and then eventually we'll get to what supersaturated means, which is not on here. So first, the solute is the item that you're dissolving in the solution. So for example, salt or sugar. So salt the items that are, dissolvable on table F. All of those will be the solute. So that's the item that you're dissolving. And the solvent is what you're dissolving it in, like water or Gatorade or fruit punch or what do you call it, alcohol. So whatever the solvent is what you're dissolving it in. So the solution is both of those together. The solute dissolved in the solvent is the solution. So that's the solute and the solvent together, and they could be made in different concentrations, some very strong, some very weak, and we'll get to that later this week. That's called molarity, the strength or the concentration of the solution. And when you look on table G, it shows you that the temperature can vary on how much you could add to your solution. So at lower or colder temperatures, for example, let's look at this KNO3 curve here. If you do have your reference tables out, feel free to look at it. If you don't, that's okay. You can take it out a little bit later. But if you look at KNO3 at a cold temperature of 0 degrees, about 14 grams of KNO3 will dissolve in 100 grams or 100 milliliters of water. This whole table is based on 100 grams of water. So if you had 100 grams of water at this temperature, that is the maximum that you can dissolve. So if I look at, for example, let's go a little bit hotter to 50 degrees, and I look at KNO3, get a marker. So if I look at 50 degrees and I follow it up to KNO3 and I look across, that's about maybe 109 grams based on this drawing. I don't have the actual reference tables in front of me, and I really should. Is the maximum that you can dissolve in 100 grams of water. If I have less than that, so let's say, for example, I only have 50 grams of KNO3. That would be underneath my KNO3 curve. That would make it unsaturated. So that's what unsaturated means. That if I only add 50 grams of KNO3 in 100 grams of water, it is not holding the maximum amount of solute that it can, because it could hold up to about 108 grams over here. So I could add, theoretically, 58 more grams of that KNO3, and it should still dissolve in my solution. Once I add more than that, it's not going to be able to dissolve anymore because it is saturated. It is holding the maximum amount of solute in my solution. So what will happen to the remaining grams that I add anywhere above this? It's going to sink to the bottom or precipitate. Okay? So similarly, let's say I had a saturated solution of KNO3 at 40 degrees Celsius. So if you have table G, and I'm going to grab my table G for a minute. And I'm going to use my actual table G, and then I'll estimate on here. So at 40 degrees Celsius, and I follow it up to my KNO3, the maximum that I could dissolve is about 65 grams. Okay, so let's look. I follow it up to KNO3, and the maximum that dissolves is 65 grams. Okay, so it's pretty accurate on here. Follow it up, about 65 grams dissolved. Now, what's going to happen if I cool this solution? If I cool this solution, okay, to 20 degrees Celsius, now my solution can only hold about 38 grams. So originally it was holding 65 grams. I cooled this down to 20 degrees Celsius, and now it holds 38 grams, which means what's going to happen here is that the remainder, or the difference between these two, is now going to precipitate. So that is about 48, 58, 58 about 50, no, sorry, about 20 something grams, about 27 grams, okay, is going to precipitate to the bottom of your cup, okay? So what I did over the weekend is I tried to put together a demonstration of what happens when you cool a saturated solution and the precipitate forms, and I'm going to send you this so you can try it at home for extra credit. Rock candy, so I have to be really careful with this because it's kind of just starting to set up. And I know it's hard to see. I'll send pictures of it later because it's easier to see in a picture. But I took some water, a cup of water, and I boiled it. And I added 2 cups of sugar, and they all dissolved. All the little sugar particles dissolved. And then I added a little bit of food coloring. I put a stick that I had rolled wet and then rolled in some like granulated sugar. I let it dry. I let the solution cool for about 10 minutes. I put the stick in the jar over here. And right now it's hard to see. Let me see if I can, if it looks, I'll send pictures. It's kind of hard to see. But there's some rock candy starting to form on this little stick. So I'm not sure what materials you have at home. I kind of just used a little chopstick. I used a chip clip, and I used some plastic wrap and a mason jar. You can use a clear glass. You can use a piece of thread with a little paper clip to hold it down at the bottom with a little pencil. And there are definitely some options of what you could do to set up this experiment. You have to, the most important ingredient is patience, because it does take time for these crystals to form. You're not going to see them immediately. You will start to see crystals maybe in about 3 hours, and it takes anywhere from 5 to 10 days to actually have like the rock candy like fully formed. So I'm testing it out at home. This is actually my first time testing it out. It looks like I just set it up over the weekend, and there are some crystals forming on my little chopstick there. So I'm going to send that out as an extra credit assignment that could be done, you know, within the next 10 days or so. There's no real like expiration date on it. You can do it at your leisure. I do ask though that the Google form that I sent out today, you can turn it in today for your attendance, but you're obviously not penalized if you're turning it in tomorrow. I accept that Google form at any time. So some of the questions on there are based on table G and some refresher questions on table F to see if something is soluble, meaning it dissolves, or insoluble, meaning it forms a solid precipitate. So some of the questions on table G ask if you have what's the maximum number of grams of, for example, NaNO3 that could be dissolved in 100 grams of water. And you would simply just use your table G. Now, if you have half the amount of water or only 50 grams of water, what you're going to do is look at what happens at 100 grams. So for example, if I have 30 degrees and I'm looking at NaNO3, a saturated solution is right here. Okay. So if and that's about 92 grams, let's write that down. So if at 30 degrees, 92 grams dissolves in 100 grams of water, how many grams are going to dissolve in 50 grams of water? Okay, so you can set up the ratio of 92 grams in 100 grams of water is equal to how many grams in 50 grams of water? And you can solve for that. Or what you can do is realize that if you have half the amount of water, you're going to only be able to dissolve half the amount of solute, and you will get the same exact answer. Okay? Similarly, if I have double the amount of water, or 200 grams of water, I'll be able to dissolve double the amount of solute at that temperature. Or, again, you can set up a ratio. 92 grams of NaNO3 dissolves in 100 grams of water. How many grams will dissolve in 200 grams of water? So we're used to doing those ratios from previous types of classes, but the idea is exactly the same. You have double the amount of water, you can dissolve double the amount of solute. You have half the amount of water, you can dissolve half the amount of solute. You have a quarter the amount of water, then you can dissolve a quarter the amount of solute. Okay, so it has a direct relationship. The other thing you'll notice about table G is that many of the curves have a direct correlation with temperature, meaning that their solubility increases as the temperature increases. That's when you're dissolving a solid in your solute, in your solvent. So for example, salt, sugar, NaNO3, those are all solid crystals that when you put it in water, as the temperature increases, the solubility will increase. Okay, so solids, their solubility increases with temperature. However, you'll see something like this NH3 curve here. This is showing an indirect relationship, where as the temperature increases, it's becoming less soluble. And that's a typical trend for gases. So for gases, let's see if I can switch this up a little bit. So for a gas, solubility decreases as temperature increases. So for example, when you have soda, right? A lot of times, once you open that soda bottle, a lot of that gas will escape. But the thing to do to keep that from going flat, not only do you need to close it, but you have to put it in the fridge. The fridge, or the cold temperature, makes more of those gas molecules soluble. If I leave it out in room temperature or warmer temperatures, that solubility of that carbon dioxide dissolved in that soda is going to decrease. So that's the trend for gases. It's the opposite. As the temperature increases for a gas, it becomes less and less soluble. For a solid, more and more soluble. And you use table G to see how much will dissolve, the maximum amount that will dissolve, or its saturation point, whether it's unsaturated or saturated, or they'll have to precipitate to the bottom. Those are different ways that we're using table G. Okay? So you do have a Google form that was sent out on Google Classroom. Do your best with it. I'm going to be online until 1 o'clock if you have any questions. And then again, I will be back online at 2 o'clock for office hours. In the meantime, what I'm going to do is I'm going to save this video. I will post it on the YouTube channel. So if you like and subscribe, you'll see it there. I'll also try and attach it on the Google Classroom. And again, if you have any questions, please let me know. I'm always here to answer questions on the chat. Okay? I hope everyone is doing well. Of course, you can email me on Jupyter, or you can email me on my HSFI. And if you have any personal questions or things that you think I should be aware of, please do let me know. I hope that you and your families are doing safe during this time. And I'll speak to you all soon. Thank you.